Hi everyone, my name is Thomas Kim. Today is December 20th, 2019. This is my 57th episode about linear algebra and threading building blocks. In this episode, we will implement LDU decomposition, lower, diagonal, and upper triangular matrix decomposition. In our previous episode, episode 56, we implemented LU decomposition. If you haven't watched my previous video, please double click this link and watch this video because my current episode continues from my previous episode, episode 56. If you haven't watched my previous video, you may not be able to understand my current session. When a matrix A is given, we decompose L, lower triangular matrix, times D, diagonal matrix, times U, upper triangular matrix. LDU factorization. In my next episode, I will explain complete pivoting or full pivoting. Then I will explain permutation matrix and I will finalize LU decomposition algorithm. Scroll down from our previous episode, episode 56. Please double click this link to download the source code from our previous episode. Show in folder, unzip, episode 57, LDU decomposition. Copy, paste it to your working directory. This is my working directory. Start Visual Studio Code. Open the folder, expand folder 57, open LU decomposition.cpp. Ctrl V. In our previous episode, we decomposed matrix A to LU. So, in this episode, matrix A, we will decompose LU prime. This is LU decomposition. Then we decompose U prime to DU. Then matrix A becomes L, U prime equals L, D, U, where D is diagonal matrix. In element wise, A00, A01, A10, A11 is decomposed 1, 0, L10, 1 times U prime 00, U prime 01, 0, U prime 11. This matrix is A, this matrix is L, this matrix is U prime. Now U00 prime, U01 prime, 0, U11 prime will be factorized U00 prime, 0, 0, U11 prime times 1, Y, 0, 1. So U prime is factorized. This is diagonal matrix times this is U upper triangular matrix. In this matrix U, diagonal elements are 1. We only need to decide this element. So if we multiply this row with the first column, then we have U00 prime. Multiply this row with the second column, U00 prime Y. Multiply this row with the first column, 0. Multiply this row with the second column, then we have U11 prime. If we compare this matrix with this matrix, this element should be identical with this element. So U01 prime equals U00 prime Y. We have Y equals U01 prime over U00 prime. Control and right before function main, template, type name, matrix type, type name, pivot, handler, return type will be auto, LDU decomposition, matrix type, forwarding reference M, pivot, handler, auto L, LU decomposition, Doolittle, M, pivot, handler. Please note that we created this function in our previous episode using matrix T DECL type L using value type name matrix T value type matrix T D. This is diagonal matrix M rows diagonal matrix. Or this is L value reference UP. P is U prime. This matrix M at this point, M is upper triangular matrix. For size Ti, I less than UP rows plus I or UPP, I say U00 UPII equal 1. This UP00, I would say UII. This UII is this element. This UPII is this element. So we set 1. DII equals UII. So DII is diagonal element of matrix D. So we set UII, this element. Now for size T, J should start I plus 1. M columns plus J UP IJ. We are applying this rule to here. UII. Now we return std pair matrix T The first element is L. The second element is D. Now scroll up. We will copy this function. Copy. Paste it here. We will rename LDU Decomposition. Copy this function name. Copy. And paste it here. I will disable this part. Now scroll up. In this function, I will remove this part. Or MA. Make a copy of A. Or LD. LDU decomposition. I would say U. We provide U and we pass this closure here. Stream L. This is lower triangular matrix. And L output print matrix. Stream L6. Copy once again. D diagonal matrix D or LDU L times D times U I will copy this once again. U, once again, LDU, LDU. Now start command prompt, dir cd 57 LDU Decomposition, clang++, std C++ 17 LU Decomposition .cpp LTBB MALLOC, hit enter. Wow, it built without error. This is our initial matrix. This is lower triangular matrix. This is diagonal matrix. This is upper triangular matrix. This is LDU multiplied together. Please compare with this code. So it works perfectly. Please note that in pivot simple, we have not implemented this part yet. I will implement this part after implementing complete pivoting algorithm and permutation matrix. Then I will implement this part. I changed the policy for source code on my videos. If you need source code, please leave a comment in the description section below this video. Then scroll down in the description section, request source code. You can find a link from this web page. Send me a message requesting source code. I provide my source code for anyone free of charge. But you have to leave a message in the comment section and explicitly request for source code. Then I will send you a download link. Thank you for watching.